So as a reminder, we are in section 3.1. We're looking at example B, and our goal here is to determine the critical values, and then if those critical values are part of the domain of the function, then we'll go back and find their critical points, the ordered pair of their critical points. So recall that critical values are the x-coordinates of a function where the function is neither increasing nor decreasing, so where the function is constant, or critical values are also where the derivative equals 0. So we're going to start by determining our domain. So if we look at 2x cubed plus 3x squared minus 12x, there are no variables in the denominator. There are no variables under the radical. This is not a log function. Therefore, our domain is all reals. All right. Now we can find the first derivative and then factor that function. So we know that the derivative of 2x cubed requires the power rule, so that would give us 6x squared plus 6x minus 12. Now that we've taken the first derivative, we can find where that function is equal to 0, which will allow us to solve for the critical values. So to factor, I'll factor out the GCF of 6, and then we'll factor our quadratic. So I'm looking for multiples of 2 that add up to 1. So x minus 2 times x plus 1 would give us our factored form. So we know that x minus 2 equals 0 at 2, and x plus 1 equals 0 at negative 1. Okay, so both negative 2 and 1 are part of the domain of all reals. So these two critical values can now be converted into critical points. Recall that 2 and negative 1 are x-intercepts of the first derivative. So to find their full critical points, we have to find f of 2 and f of negative 1. In other words, we have to plug our critical values back into the original function. So let's do that now. So that gives us 2 times 2 cubed plus 3 times 2 squared minus 12 times 2. 2 to the third is 8, and 8 times 2 is 16, plus 2 to the second is 4, and 4 times 3 is 12, minus 12 times 2 is 24. So 16 plus 12 is 28, and 28 minus 24 is 4. So we have a critical point at 2, 4. We know that that is either going to be a relative max or a relative min of the original function, so we refer to that as a relative extrema. Okay, and then let's solve for f of negative 1. So 2 times negative 1 to the third power plus 3 times negative 1 squared minus 12 times negative 1. So negative 1 to the third power is negative 1 times 2 is negative 2. Negative 1 squared is 1 times 3 is 3. And negative 12 times negative 1 is plus 12. So negative 2 plus 3 is 1, and 1 plus 12 is 13. So we also have a critical point on the original function at negative 1, 13. Don't forget to look at the videos for examples C and D, and tomorrow we will talk about how do we determine if these relative extrema are minima or maxima. Thanks for tuning in.